So welcome in this class. In this class, we are going to discuss the equation of hyperbola when the center is shifted away from the origin and the transverse axis is shifted away from the x-axis or the y-axis. So equation, so following our previous classes, so then let's call this one, this case C, the hyperbola with center HK, transverse axis, parallel to x-axis. So let's draw the sketch. So x-axis 0, y-axis. So we are saying that this is going to be our transverse axis, which is parallel to the x-axis. And then let this point be our center. So let me have this. So let this be our center with coordinates h, k. And then let the arms of the hyperbola be this. So let this be the arms of the hyperbola. So which tells us that this will be our V. So let's call this one V2. Let's call this one V1. And let this be F1. Let this be F2. So when you relate this one to what we did in the first class, you realize that actually that is more or less the same thing that we did in the first class, but the difference is that now we have shifted the graph away from the center away from the origin. So because the case where we had this being the x-axis, the equation was x squared over a squared minus y squared over b squared equals to 1. Then the equation of this hyperbola will take the same structure, but know that there's a shift of h units in the x and a shift of k units in the y. So therefore, equation, so let's just start discussing one by one. We are not going to go into the derivation, but you can do that anyway to get this. So the first thing, equation of the hyperbola, if this is the case, will be given by x now minus h, because there's a shift of h units in the x, over a squared minus y minus k squared over b squared equals to 1. So that's how the equation looks like. And then still b squared is c squared minus a squared, and c is greater than a. So that's the equation. And then the next thing we'll be interested in now, knowing the coordinates of the vertices. So from this diagram, you see that because this already we know that the distance from at the center to any of the vertices is always a units. the distance from the center to any of the foci is C units, then we can use distance formula to find those coordinates. So if you can dot this and then dot this, and actually you can actually do the same thing for this. Do this. So then actually I can elongate this one because I also study about the lattice term. So this, because we know this point as hk, then this must be h, and then this must be k. This point must be k. And then because we know that this distance is always a units, then to the left, this will be h minus a. And this distance from here to the center is always small c units. So to the left will be h minus c. This distance is always a units. So this would be h plus a. From the center to the focus is c units. So this will be h plus c. So that you say the coordinates of the foci, coordinates of the vertices. So V1 would be simply given by x value is h plus a comma k, and V2, this is given by h minus a comma k. And then foci, you can easily read the coordinates, will be F1. F1 here we have h plus c, comma k, and F2 will be h minus c, comma k. For this we have h minus c. And then there's what we call eccentricity. Eccentricity is the ratio of c over a. So this is the ratio given by the distance from the center to the focus over the distance from the center to the vertex. So this is what we have. And then this value is always positive, and because c is greater than f for the case of hyperbola, then e is greater than 1. So that's what we have for this given hyperbola. And then in the next session, we'll study about how to find the coordinates of the vertices and foci and eccentricity, and also the equation when the transverse axis is parallel to the y axis. So thank you.